Hi-ho, reflection. Here we go. Reflection, by definition, it happens when light, or I guess it could be sound, hits an object and returns without changing the medium it's in. In other words, you might think of it bouncing off a wall, off a mirror. It doesn't go into the mirror, into the wall. That would be a partial reflection when some of it actually goes through. Here's some terms you need to know. One in particular I want to point out is called the normal. The normal is an imaginary line, and it's dotted. Usually when we draw anything dotted, it's an imaginary line. We draw this for convenience, and there's a reason why we have this thing called the normal. All laws of reflection are measured with respect to this normal. This normal is an imaginary line, as I pointed out, that's drawn perpendicular to the surface. How do we know where on the surface to draw it? Well, you draw it wherever your incident ray, in other words, the ray that's coming in, strikes the surface. So if our incident ray landed there, we would draw our normal at that point of contact. The reflected ray is exactly as it sounds. It is the ray that's reflected away. We have two angles to concern ourselves with. We have the angle of incident. It's the angle made, in other words, number of degrees, from the normal that the incident ray is. It's not, I repeat, not this angle from the mirror to the incident ray. Likewise, the angle of reflection is measured from the normal to that reflected ray. The law of reflection states that those two angles are equal, the angle of incidence and the angle of reflection. This is the Greek letter theta to represent the angle, and the little I for incidence, and the R for reflection. We always have to measure from the normal, because if that mirror was not planar, it might drop off, as you can see, in which case our angle would be not the same. But if we measure things from the normal, we find that the law of reflection always holds. Always. So let's apply this to a situation. If you want to signal a plane with the light from a mirror, where should you aim the mirror? So we have our plane up here, we have our guy, right? He's got a mirror. We want to signal the plane. Are you going to angle it or aim it at the sun, at the plane, or somewhere in between? Well, I hope you would say in between, because if you want, right, there's our normal. If you want that light to hit, that normal has to bisect the number of degrees from the sun to the plane. Now, not all surfaces are smooth, as you probably realize. Here you can see it, this thing called a smooth reflection. The angle coming in is equal to the angle coming out. We can draw in the normals, and those angles will be the same. But if it's a rough surface, again, as I pointed before, if you don't draw it with respect to the normal, it won't be equal. But if you draw the normal, regardless what that surface looks like, those two angles are the same. So those rough surfaces we call diffuse reflections. This is the type of reflection you normally get when you look at your paper. Well, you look at anything, because if it's a perfectly smooth reflection, you won't see any light coming off of it. A really good example that you might be familiar with is when it's raining out and it's dark. The rain has filled in the little holes and cracks on the highway, and because of that, it makes a nice smooth surface. Your headlights hit, but you don't see the road reflected back at you. It's very difficult to drive. So it doesn't matter whether you're talking about the smooth or diffuse reflection, the law of reflection always holds in every situation. Everyone, it doesn't matter. Let's take a few moments and talk about the types of images you could get. A virtual image is the one you're most likely familiar with. It's the one you see when you wake up and look in the mirror. If it looks like your image is back into this imaginary world of the mirror, like you're looking in and it looks like a whole new world back there, you know you can't walk into the mirror, but it looks like it's there, there's something there, that's a virtual image. Those images are always upright. Again, they're always behind the mirror. They appear that they're behind the mirror and they're in that virtual world, hence they're a virtual image. Real images are pretty cool because it looks like it's real. Like there's a real object sitting there. And those are always inverted. In other words, flipped over. They're always in front, or in other words, in the same side of the mirror that you exist. Not back behind, but in front of it. And the really cool thing about this, you can project it onto a screen. For plane mirrors, realize we have curved mirrors, right? A concave, light's coming in this way, convex, and then a plane, a flat mirror. When you look at the image, we know the light had to reflect from our object off the mirror to our eye. Again, law of reflection holds, those two angles are the same. Study this drawing a while and see if you can make sense of exactly why you see what you see. The difference between a plane mirror and a curved mirror that gives you a virtual image is with a plane mirror, the images always appear the same size. They're still upright, they're still virtual. Oh, and the distance is the same. If you're 2 feet in front of the mirror, well, the image is going to appear 2 feet behind. Lastly, real life example, how big a mirror would you need to see your entire body? It turns out, remember law of reflection, half of your height. So if you're 6 feet tall, you only need a 3-foot mirror. Think about it. You don't need to look all the way down at your feet to see your feet. You only look halfway because the law of reflection says that angle of incidence is equal to the angle of reflection. So I'll let this run through so you can read this, and then we'll close it up.